Okay, it's time for the class. Okay, start joining the class now. We are about to kick off the class. We are about to kick off the class. If you can hear me, just say you can hear me. Okay, if you can hear me, we are waiting for others to join this class now. So if you can hear me, just say you can hear me. Can you guys hear me? So we are still waiting for others to join this class. If you can hear me, say you can hear me, so that I'll know that you can hear me at your end. Okay, if you can hear me, say you can hear me. I want to I want to hear from you guys. How you guys doing? Yes, you guys are joining the class now. Nice one, nice one. So we are still waiting for others to join this class. Remember, your exam is actually coming up, and that is why we want to do this live class. So this live class is to ensure that you cover some most important aspects in K1 Q1 before we are going to start our general tomato class. But as we wait for others to join, now let me just take you on what we are going to do. Please, if you have not liked this, if you have not liked it, please give it a like. I'm seeing 0 like there. Please give it a like. I want to be seen like there. Please give this live class a like. Yes, it's very important. Give this live class a like. Please make sure you are with your pen. Please make sure you have your pen and your calculator. Make sure you have your pen and your calculator. Your pen, your notebook is okay. Because I want to cover a whole lot of things in this word class. I want to cover a whole lot of things in this class. Just thank you very much. Okay, no, it's right. I read you. So now let's look at what we're going to look at, chemical equilibrium. So let's look at what chemical equilibrium. Let's look at what chemical equilibrium. So now in this part of chemical equilibrium here, we are going to look at what writing Kp and Kc expression. So how do you write Kp and Kc expression? So for chemical equilibrium here, the first thing you want to look at is what writing Kp and Kc expression. And I want to teach you everything to know when it comes to what writing Kp and Kc what expression, because you're going to see this question in the exam. Then after that, we're going to look at what calculation of Kp and Kc. How do you calculate Kp and Kc when the equilibrium constant, when the equilibrium constitution is given to you? Yes, we have to solve a lot of problems. Yes, we have to solve a lot of problems. Just and so just pay close attention. Now the next one I want to look at what calculation of equilibrium constant and pressure. So these are things I want to look at in this class. So it's going to be an intensive online class to prepare you adequately for your exam, right? Others will join this class, so we don't have time. This class is just about 1 hour 30 minutes. I don't want this class to exceed 1 hour 30 minutes. I don't want this class to exceed 1 hour 30 minutes. So let's get into it. If you are ready for this class, leave a message that you are ready for this class. Please take all this down. These are the things you have got. These are the things you are doing today. This class. So please leave a comment section. Like, take it down. Copy it down. Copy it down. Copy it down. If you have finished copying, just say you have done copying, so we can continue, can start working in class. So what is chemical equilibrium? So that we are starting. What is chemical equilibrium? What is chemical equilibrium? Again, now the word chemical means what? A reaction. Chemical what? Reaction. Again, and equilibrium means that we're in a balanced what state. Do you understand? So balance states. So now when we talk about chemical equilibrium here, there is a reaction that is what is reversible. I'm going to explain to you. Just hold on. So for a reaction to be chemical equilibrium, or for a reaction to be chemical equilibrium, the first thing we want to understand here is that it must be a reversible what reaction. It's okay. It must be what a reversible what reaction. It must be a reversible what reaction. Now, what is a reversible reaction? Is the type of reaction in which what reactants move to produce what the products, either while the could also react back to produce what the reactant. Just so this is called a reversible what reaction. A reversible what reaction. So we talk about chemical equilibrium here. You have to talk about a reversible what reaction. Now, a reversible reaction is type of reaction in short, as the reactant react to produce the products, the product also react back to what produce what the reactant. That's called a reversible what reaction. Just this is called a reversible what reaction. So it's called chemical what reaction. So the chemical reaction we're talking about is called a reversible what reaction. Hope you understand. A reversible what reaction. That's what we're talking about. A reversible what reaction. Now, remember, A is producing what B, and B also reacts to produce what A, right? Now, to get to a point, because here we have rates of forward reaction. Okay, rate of forward reaction, that is producing what the products. They also have what rates of backward reaction. Just so here we have rate of forward, that is the reactant is moving to the product, while the rate of backward product is reacting to produce the reactants. Just so that is called a reversible reaction. So we talk about a reversible chemical equilibrium, a reversible reaction. Now, it now get to a point where the rate of forward reaction is equal to the rate of backward reaction. Now, if you say that the rate at which A produces B is also the same rate in which what B produces what A. At that point, you say the reaction is at equilibrium. Do you understand? So, what is chemical equilibrium? Chemical equilibrium is the reaction is the point in which the rate of forward reaction is equal to the rate of what backward reaction. Do you understand? And if you ask me an exam, what type of equilibrium reaction is this? It's called dynamic equilibrium. It's called dynamic equilibrium. Let me go by it again. When the rates of forward reaction is equal to the rate of backward reaction, we say the reversible reaction is what is at equilibrium. Just and what type of reaction is that? What type of equilibrium is that? It's called dynamic equilibrium. It's called dynamic equilibrium. So the word dynamic means that it's moving at the same rate. It say that the rate at which A is moved to produce B, it's not the same rate which B is with what A. So it's called dynamic. Remember, in physics we have called static equilibrium and dynamic equilibrium, right? So static equilibrium means that it's just static. Dynamic equilibrium means that it's moving, but at the same rates. Hope you understand the concept. So the type of reaction, the type of equilibrium reaction here is called dynamic equilibrium. Dynamic equilibrium. Do you understand? Now, every equilibrium reaction has that equilibrium constant. That's what we call the reaction constant. Just like call equilibrium constant. Again, it's falling here. Let me close this place. Okay, so I'm back. Please, if you are following this class, just leave a message that you are following this class. If you are following this class, leave a message that you are following this class. Leave a message that you are following this class. Okay, so we continue the class here. So yeah, it's called dynamic equilibrium. It's called what? Dynamic equilibrium. That's called dynamic equilibrium. So now let's consider a general reaction. For example, you have A plus B, give me what? C plus D. It's okay. This is called a reversible reaction. Just here we have the reactant, here we have what products, right? So the rate at which A and B get to produce C and B is not the same rate. In short, C and B get to produce A and B. Just so when you get a forward reaction to the rate of backward reaction, say what the reversible reaction is what is at equilibrium. Is that what is at equilibrium? Hope you understand. That is it. So now, another thing you want to look at here is what is concept of writing equilibrium constant. How do you write equilibrium constant? Equilibrium constant. Equilibrium what? Constant. I get. And now two types of equilibrium constant. There are what? Two types. We are called Kc and what? KP. Are you there? Now, what is KC? Now, what about KC? KC is a constant in terms of concentration, just as equilibrium constant in terms of concentration. Right there. Equilibrium constant in terms of what of concentration. Then you can look at what the concentration of the reacting of species and products. I want to explain that to you just from here. The other one called KP. Right there. KP is called equilibrium constant in terms of what of pressure. In terms of pressure. Right? So now writing equilibrium constant expression. So how do you write equilibrium constant expression? How to write equilibrium constant expression. How do you write equilibrium constant expression? Writing equilibrium constant expression using our law of mass action. Law of mass action. Law of mass action. Just a law of mass action. So how do you write equilibrium constant expression? It's very easy. What is very easy. You understand? So equilibrium constant expression which was KC NYU space out. Equilibrium constant expression now KC was what? Concentration of what? Of the product. Get out the coefficient. It's okay. So I hope you can see. I hope you can see it. So you have concentration of the product. Get out the balance what coefficients over concentration of the reactant. Get out coefficients. This that. So now this one for the concentration. Now when I see a square bracket here means what? Concentration. It means what? Concentration. Right there. So when I see a square bracket, now the unit of concentration is what? Is mole per dmq or mole per what? Liter. Or you can say or mole per liter. Just as mole per dmq or mole per liter. Please, these are very, very important because I want to use them. Just as so now this was for the KC. Remember, what is KC? Equilibrium constant in terms of concentration, just as K equals to what? Equilibrium constant equals to what? Concentration of what? Of the product. Get our coefficient. Coefficient means what? The balance coefficient. Yes, the balance of coefficient. Just as here we have A, B, C, D. The smallest is just what? Pressure, total pressure of the what? Product. Against what? Coefficients over what? Partial pressure of the reactant. These are what? Coefficients. Do you understand? Now, this one you see here, this P is called partial pressure. Just as it's called partial pressure. It's called partial pressure. And it's called partial what? Pressure. What is partial pressure? What is partial pressure? The unit is what is KCN. Please differentiate between KC and what KP. KC is what is instead of concentration. That's why you see square brackets here. KP is what is pressure. So I leave a question that we are following class. So let this class be interactive, please. Let the class be interactive. Please Try to inform your friends and classmates so that they can join this class. I wish I are using Zoom so I can hear from you guys too. And I can hear from you. It's only typing. Please, if you have not liked this video, please like this video. Not clear. Probably it's network at your own end. Probably it's network at your own end. Network is disturbing. Now, okay, some of you are not seeing the board. You can see the board. If I can see that, I can see the board. You can see the board. If I can see that, I can see the board. It's like network is actually disturbing this class. But I want to know if anyone can see the board. If it's general or some persons. I just want to know. The write up is not visible. Okay. Say that the write up is not visible. Oh, that is, I want to like improve on the writing. What is again? What is again? Now someone said that the write up is not visible, which I want to work on. I want to work on it. So far, so now here we have the case and what case keyword expression. So what we want to do now is to writing writing equilibrium constant expression. Writing equilibrium constant expression. So can you also see this one here? Can you also see this one? Probably it's network. It's network. So writing equilibrium constant expression. Writing equilibrium constant expression. So we have to take some few questions. Now we want to take a few questions here. So question one. Question one. Let's take question one. Let's say what question one. Let's say what question one. Write write the equilibrium. Write the equilibrium constant expression. What? KP and KC. Idea. Write the equilibrium constant expression KP and KC for the following. For the following what? Reaction. So, okay, now let's say what first question here. Write the equilibrium constant expression KP and KC for the following what? Reaction. So let's say what the first question. Let's say what the first question. So A, here we have 2SO2 gas plus O2 gas. Here we have this one here. 2XO3 what? Gas. Now, do you want the first one here? Please declare to be an interactive class. Do you understand? Please, I want you guys to pay attention. For those of you who network are actually disturbing me, don't worry, the class will also be available here for you to come and what check that. Do you understand? So it doesn't mean that if you miss class now, you're not going to this class again. So I'll make sure that this class will be still available for you when you come back. Do you understand? I understand that suppressors are not actually available now. Why network is actually what disturbs suppressors? I understand all this factor, right? But if you know that you can still take part in this class, it's very important. And I want this class to be interactive. I'm actually checking the comment section I'm actually was checking your current session. Please, if you have any issue with reading my current session, I'm kind of focused there to what to check the comment section. Please, if you have not give this video a like, please give it a like. If you have not taken to give this video a like, please give this video a like. I'm only seeing 2 like there. I'm only seeing 2 like. Please give this video a like. Please give this video a like. Right? So now let's first one here. Write the equivalent constant expression of cases and cases for the following what reaction. So here we have the first one. B. 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 Here we have CO gas plus H. Here we have 2H2 gas. Here we have CH3COH gas. It's okay. Here we have this one. Then you have C PCl5 gas. Here we have PCl2 gas plus Cl2 gas. Right, that. Then you have D2NO gas plus Cl2 gas. So you have 2NOCl gas. So how do you write the KP and KCl for this work reaction? Please look up. I will use this A and B. It's okay. Then you do what C and D for me. It's okay. Now, this is a beginner class. It's okay. This is a beginner class for chemical work equilibrium. It's okay. It's a beginner class. So then it's going to be what like a part 1, like you want the first part. Then we're going to see part 2, part 3, and what part 4. Please, if I want to do video here, I am not doing this video like, and you are hearing me like witchcraft, just which is worrying you. So if you are watching this video, you cannot do this video like why? I'm still to be like there. What does it take you to do this video like? I'm asking you. What does it take you to do this video like? This is called witchcraft. Some of you are doing witchcraft here. And it's not good. It depends. So I will not born you. Okay. So I want to do A and B. They do what C and D for me. It's okay. Do you understand? Nice one. This is what I'm talking about. Give this video a like. I'm still 3 like. I want to say Obu will kiss some person, but Obu will not kill anybody. So please give this video a like. I just got to hear this. Give this video a like. Give this video a like. Okay. So I want to do A and B, then do C and D for me. It's okay. So let's get into it. Let's get into it. Remember, this is a live class. This is not like a class that is pre-recorded. It's okay. It's a live class. It's a what? Live class. Yes, it's a live class. So let's do the first one here, right? Remember, I told that if I have, let me show you something. But for example, I have A gas plus B gas. Here now I have what? C gas plus what? D gas. Now, this is what is a balanced equation. Do you understand? This is what is a balanced what equation. The what? It's a balanced what equation. Yes, it's a balanced equation. So now, how do I take for this reaction here? Because this understand here, we are going to write it here. Do that. So yeah. Now remember, K. This is our coefficients, right? Coefficients over what? Concentration of reactants. This is what coefficients, right? It's okay. Now, if you look at it here, there will be Kc equals to what? Here we have A and D, C and D, right? So it will be concentration of D gas. This one what? C. Is it clear? Then concentration of, sorry, here we have C. Concentration of C as our question. Then concentration of D gas. This one what? Question. Do you understand? Over what KP. Something you're going to be partial pressure of what of products. Products. These are our questions. These are our questions. Just as these questions. Pressure of reactants. These are what questions, right? I believe you understand the rest of our questions, right? Now, if you want to do for this reaction here, you have Kp equals to what? You have partial pressure of C gas. This one C. Then partial pressure of D gas. This one D. Right? Over. Let me take this down. It's okay. Right? So these have to work to run it here. Remember, I'm having gases here. This is called homogeneous. Homogeneous means that they are in the same state. They are what? They are in the same state. It's network. Network is disturbing. Following class. So now these are the words, are the ways that used to work to write the case now of case word expression. So now let's take the first one. Let's take what the first one. Let's take what the first one. So please can take it down so I can take what the first one. So let's take what the first one. You have 2SO2 gas plus O2 gas. You have 2SO2 gas. Can you see that? Now let's know what the Kc and Kp expression for what for this reaction. So now the Kc equals what? Concentration of the product, right? Remember, it's a gas. So you use gas. I'm going to show you something here as we move on. We use what gas, so we're going to be this for what? So it's okay. We only gas, this for what? Two, right? We have O2 gas, this for what? Just as so this is called the equivalent constant expression for this what reaction here. Now, for the Kp, so we're going to go pressure, partial pressure of CO3, SO3 gas, raised by what? 2 over partial pressure of what? SO2, partial pressure of what? Of O2 gas, raised by what? Raised by what? 1. So this what Kc and Kp is for what? This what reaction. Do you understand? Sorry. 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 Please, sorry. That guy want to kill me. Okay. So please copy it down. It's very easy. It's not that difficult. Just it's not what difficult. It's not difficult. So take it down. I'll give you some chimneys here to take it down. Then let's move to what the second one. Remember that you do C and D for me. It's okay. You take it one. So that is for this first one. If you understand the first one, please leave a comment that you understand the first one. You can't see. Sorry. Network is network at your own end. Network at your own end. Network at your own end. So let's look at what the B part. Let's look at how to write a previous constant for what will be. So C and D will be your what your assignment. It's okay. So let's look at what the B part here have CO gas, right? Plus 2H2 gas. You have CH3COOH gas. It's okay. So how do you write the equivalent constant expression here? This equation is only this is supposed to be C. Right? There's something wrong with this. Okay, it's correct. CO. Okay, it's correct. It's correct. So here we have this one here. So how do you write the KC and KP expression? So KC equals to what? Concentration of what? CH2OH gas over what? You remember here is one, right? So we never do one, but they don't put the 51, so you read like that. They have CO gas, right? Is one. They have H2 gas. This one two. That is it. Therefore, the KP equals to what? Pressure, which was PCH3OH gas over what? PCO gas, right? They have what? PH2 what? Gas. Which one? Two. That is it. So you take C and D as well as assignments. Please, we cannot continue this class again because of bad network. Yes, so many of you are complaining that it's bad network. You understand? So many of you are complaining of bad network. You see how you can fix the word bad network. So we are not in class here due to bad network. The services I really want to teach in this class for, but due to bad network, we may not continue with this class. It's okay. So, but I believe we are going to see something here, right? So I want to end this class here. Probably we are going to have part two of this class. Just but now I really want to appreciate those of you who came online. Just I really want to appreciate of those of you who came online. There's a place that says that they cannot see class. I will re-upload the video again so that those persons who are not online can actually see it. Okay, you submit at my DM. Submit the assignment at my DM. It's okay. Submit the assignment at my DM. Then our WhatsApp group, right? So then our WhatsApp group here. Because submit the assignment at my DM. Or if you don't have my number, in case some of you sometimes just join this class and you don't have my number here. This is my number 07037627429. It's okay. This was my WhatsApp number. You send me a WhatsApp number with let me check it here. You understand? So I really wanted to continue. So I really wanted to continue, but due to bad network, I'll end class here. But class, we have the class and we consider what basics. Just thanks for being part of this online class. So we are done for today. How do I end this live?